Hi everyone, welcome to the brand new section, Handling Big Data. In this section, we will train and apply an online logistic regression model using Apache Mahout. We'll then solving simple text mining problems with Apache Spark. We'll perform clustering using k-means algorithm and create a linear regression model with mlib. Lastly, we'll classify data points with random forest. Now we move on to the first video of this section that deals with training an online logistic regression model using Apache Mahout. In this video, we will use Apache Mahout to train an online logistic regression model using Apache Mahout Java library. In Eclipse, we create a new Maven project. Then, expand Maven from the wizard and select Maven project. Click on Next until you reach the window where Eclipse prompts you to provide an artifact ID. Type in com.data.big as group ID and Mahout as artifact ID. Click on Finish. This will create a Maven project named Mahout. We click on the Pom.xml tab. You will now see the Pom.xml file on screen. Put these lines in the Pom.xml within the dependencies tags and save it. This will automatically download the dependency jar files into our project. Create package science.data and click on Finish button. After creating, we right-click on the project name in Eclipse, select New, and then select Folder and name it as Data. Repeat this step to create a folder named Model. We have created two folders. The first folder is data that will contain the input dataset for which you will be creating the model. The second folder is Model, where you will be saving the model. Now go to Data and create a CSV file named weather.numeric.csv and click on Finish button. Add data. Save the file. Now we are ready to code. We create a Java class named Online Logistic Regression Train.java and click the Finish button. We throw an exception which we import from Java util. We create two string variables to contain the input data file path and the path of the model file that you are going to build and save. Now create a list to contain the features of the data file. This will list all the feature names of your data file and according to their order of appearance in the data file. Next, we define the type of each of the features. A feature type W denotes a nominal feature, and a feature type N denotes a numeric feature type. Now is the time to set the parameters of the classifier. We will be creating a parameter variable and set a few values as parameters. We will set the target variable or class variable. If we take a look at the data, we will find that the class variable play takes up most two values, yes or no. We will set the maximum target categories to 2. Next, we will set the number of features that are not class features. The next three parameters depend on the algorithm. We will not be using any bias for the classifier generation, and you will be using a balanced learning rate of 0.5. Finally, we need to set the features and their types using a type map method. Add this line to create the classifier using 50 passes. This number is arbitrary, and you can choose any number empirically found by you. Now we create the online linear regression classifier. We then add a variable to read the data from the CSV file and start creating the regression model. Add a k integer to the code. Next, we will create a for loop to loop through each of the 50 passes. This will start reading the data file. Adding this line will get the header of your data file, which is comprised of the names of the features. This line of code reads the data row. Now we will loop through each row that is not null. Now for each row, we add this line of code to display the data point and create an input vector. Add this line of code to get the target value for the row. Now we train the model with this data point. To read the next row, include this line. Now close the loop. Close the reader to read the input data file. Close the loop for iterating through passes. Finally, we save the output model to a file named model inside the model directory of the Eclipse project. Close the main method and the class. We run the code. You will see the data rows of your input data file on console as the output. And in the learned model, it will be saved in the model directory of the Eclipse project. In the next video, we'll apply an online logistic regression model.